This is GMAT 41. You are welcome to our Introduction to Calculus class. In this video, we are going to focus on the topic limit. So we're studying the concept of limit of a function. And what is the limit of a function? It's simply the value to which that function approaches when the variable in that function approaches or tends to a given value. Now that value it tends to can either be a constant, can be infinity, or it can be an expression that contains a variable as well too. Now I mentioned infinity, please. It's important for you to know that infinity is not a number. Is that okay? It's not a real number. It's a quantity whose property is far greater than any real number you might think about. Now we have properties of 0 and infinity that you should know. We have 14 of them, and then we have others that leads to indeterminate terms, meaningless terms. So you can't even get your result. They don't have answers, alright? And in these properties from 1 to 14, it's on the condition that a is not equal to 0. Then a can be greater than 0, which is a positive number, or a can be less than 0, which is a negative number. Expectedly, please, you have to memorize these properties as much as you can. Now, you want to look at property number 1 to 14. If you really look at it, you notice that it's actually dealing with the constant a, which could be less than 0 or greater than 0, and then infinity. Now, areas that we have 0 in the operation, it's when you're dealing with 0 and the constant, alright? Not 0 and infinity. Take note of that. You can see that here where 0 was introduced. Take note here, a divided by infinity is 0. 0 is not in the operation here, you know that, right? Okay, now in the indeterminate term, if you look at it much more, you see that you're dealing with infinities and zeros specifically. Then look at this, 1 raised to infinity, 0 raised to power 0, infinity raised to power 0, they are also indeterminate, they don't have values, okay? So before now we used to know 1 raised to anything, power of anything is 1. And any number raised to power 0 is 1 as well. So please, that does not include these terms here, right? So you want to take note of them. Now in the next video, we're going to pick questions to see how we handle problems like this. When you encounter indeterminate or meaningless terms, then you need to introduce certain concepts of mathematics, sometimes do certain differentiation or do certain division so as to be able to work around it and actually get your result. Now we have our first question on the board here on the limits. We have to find the limit of the function x squared plus 2x plus 1 as x tends towards 2. So you see we're given the function is a function of the variable x. So we have f of x is equal to x squared plus 2x plus 1 as x approaches, tends to 2. It's important for you to know, yes, x is not actually 2 here. It tends, it approaches, that don't get confused. I'm just saying this because there are certain type of questions we're going to encounter subsequently where this fact that x is not exactly 2 will become very important. Anyway, until we get there. For this problem, we're going to substitute x equal to 2, right? In this function. And if we do that, this is going to give us, we'll come to this function and you will see x, we put 2. So that's going to be 2 squared, and then plus here, this is 2 times the value of x is 2, then plus 1. If you simplify this, 2 squared will give you what? 4. Then 2 times 2 will give you 4 plus 1. 4 plus 4 is 8 plus 1 is 9. Therefore, f of x, which is equal to x squared plus 2x plus 1 as x approaches 2, will give us the value 9. So, okay, so when x is approaching 2 here, f of x in this function will be approaching what? 9. And that's the solution to this problem.